Hey everyone, here are your light-dependent reactions. I'm going to start by drawing your thylakoid membrane and separating out the stroma from the lumen. I'm drawing your photosystems, so this is going to be photosystem 2, which is the first photosystem in our light-independent reactions. Your B6F, photosystem 1, your NADP plus reductase, and then your ATP synthase. Okay, so what we talked about in class was how photosystem 2 is going to absorb light at a particular wavelength, so it's given the nickname P680. It's going to take water and split it for the electrons. Water will become hydrogen, and eventually you're going to have your molecular oxygen, and this is going to leave because it is small and nonpolar. It can exit the outer membrane. The electron is going to get energized by light and then moves to the B6F. Now your B6F is a proton pump, and so it's going to pump hydrogen into the lumen of the chloroplast, creating a hydrogen ion concentration gradient. Hydrogen will not be able to exit or go down its concentration gradient unless it travels through ATP synthase from the lumen into the stroma, and as it's moving, ATP synthase is going to phosphorylate ADP into ATP, and this is with the addition of inorganic phosphate. So it's that proton motive force that's going to phosphorylate, provide the energy for phosphorylation of ATP. Meanwhile, the electron gets sent to photosystem 1, where it gets recharged again. And then the electron is going to end up at NADP plus. We're going to reduce NADP plus down to NADPH. And the NADPH is going to eventually be used in your Calvin cycle. And so in this case, NADP plus is our final electron acceptor. Instead of an oxidative phosphorylation, oxygen was our final electron acceptor. Well, now it's going to be NADP plus. And so because the electron is now tied up in NADPH, a new water molecule is going to have to be split for a new electron, producing more oxygen, contributing to that concentration gradient. But the reason this is called non-cyclic photophosphorylation is because the electron ultimately ends up tied up here at the NADPH, and therefore you have to harvest another electron from the water molecule. I hope this helps you guys. Thanks for watching.